Greetings, Patriots. In today's lesson, you will be introduced to looking at the difference between a relation and a function. So please don't forget to take the time to set up your notebook. The question you will have to answer in your discussion question today is, what is the difference between a relation and a function? So let's go ahead and get it. Our objective is that you will identify the difference between a relation and a function. So let's take a look at the following question. The question being asked is, what is the relationship between money that I place in a vending machine and snacks? So think about just a vending machine you see at Walmart, etc. Well, let's say the vending machine costs $1. Well, if I think about it, if I insert money, if I insert $1, I have choice. I can either insert $1 and get a pretzel, or I can get a chip, or I can get a candy. So the relationship between the money and snacks is if I enter any money, right, I can get any type of snack that I want to eat. So let's look at this in various representations. So there is a relationship between the money that I input, there it is, the money that I input into the machine will give me an output. And hopefully you begin to remember some of these words, input and output tables, okay? So I can represent this relationship in a table, and something that you will be asked to do in this unit is draw a mapping diagram. So let's think about it. In my input value, right, let me go ahead and stick to my color red. In my input value, if I enter $1 into the machine, I can get my output of a snack. So I can get a chip, I can get a pretzel, or I can get a candy. I have choices. I can also take that information that I find on a table and represent that in an ordered pair. So when I think about an ordered pair, remember what makes up an ordered pair? An x coordinate and a y coordinate. And in this case, my x coordinate is the $1, and the output, or the y coordinate, is my chip. Or I also, if I take the ordered pair from the table, $1 can give me a pretzel, or $1 can give me a candy. So a relation is just a relationship between a set of ordered pairs. And I have a set of ordered pairs here when I look at the input of $1 and the output that I receive in a vending machine. Here's a graph. If I take the following and I label my x-axis, right, as the money that I placed into the vending machine, well, my y, my output here, would be the type of snacks that I can receive. So if I take this and graph it, there is a relationship that if I input $1, I can get a chip, or I can get $1, I can get a pretzel, or I can get a candy. Okay? So as we think about a relationship, I want you to think about, well, how does the map, how does the ordered pair, how does the graph in the table, as we begin to compare it to our next example, how does it look the same and how does it look different? So remember, I can represent a relation in multiple ways: a table, a mapping diagram, an ordered pair, and a graph. Go ahead and look at the next situation. So here I'm just asking, well, what's the relationship between the buttons on a vending machine? So when I talk about that, think about these buttons here that you have to actually press. What's the relationship between the buttons on a vending machine and the snack that I get? Does this relationship change a little bit? So I want you to think about this word, okay? And the word is function. A function is kind of like a vending machine. We're going to enter a specific input code, right? And that's going to give us an output. So out comes a snack. I enter a code and out comes a snack. So if you think about it, I would have a specific input code, right? So like D1 or D2, and that is going to be related to a specific output value, right? So I'm going to get a specific snack now when I enter that one code that relates to that one output value. So let's look at this particular table. If I input D4, well, D4 is specifically connected to a pretzel. If I enter C2, well, that specifically is tied to chips. If I entered the code of C3, well, that's specifically tied to a candy. So a function is a little bit different than a relationship in regards to it is a special relationship where each input has only one particular output, okay? So here, that code is connected to one output value only. All right, now let's look at a function in multiple representations. So when I look at a function in multiple reps, I can take that code, right, that input value of D4, and that'll give me specifically my chips or my pretzels, etc. I can organize the function in a multiple representation of a table. I can also organize that in a mapping diagram. So notice that my input values, right, now look a little bit different because D4 is connected to that chip, right, that one particular output. C2, when I enter C2, it is connected directly to a pretzel. And if I enter C3, it is connected directly to a candy. So here's my graph. You can see that here's my input values, right, and my output values of the type of snacks. So now your graph begins to look a little bit different, right, than that one of a relation. Because every input value, right, so every input is assigned only one output value. It's only assigned one. Every input is assigned one output. So here you can see that I can take the table of values and place them in an ordered pair. So keep your eye on that input value. Every input is assigned only one output value. So think about it. What was the difference just between a relation and a function? What was special about a function that not necessarily, as I compare it to relation, was the same? Why is a function considered a special relation? We will talk about this more in class tomorrow. Have a great day.